Hi team, welcome to Wiggins Maths. In this video we're going to be having a look at the concept of the sum to infinity. Now the sum to infinity can only work if we're looking at a geometric series, and we're looking at a geometric series where the common ratio is between -1 and 1. The modulus of r is less than 1, and we'll sort of have a look at why that is the case in a moment. Firstly, we need to have a look at the difference between a divergent and a convergent sequence. Okay, so a divergent sequence is one that jumps off to infinity. Okay, so this one's doubling every single time, so it's bigger and bigger and bigger and bigger, or it could be getting more negative, more negative, more negative, more negative. Okay, so that is a divergent sequence. A convergent sequence is one that converges on a particular value. Often it is 0. So this one's halving each time. So the number's getting smaller and smaller and smaller and smaller and smaller and smaller and smaller until eventually, if we could continue this sequence forever, it would get to 0. Okay, so that is a convergent sequence. So if this was a series, eventually it's going to be add 0, add 0, add 0, add 0, which is not going to do a lot. So here we have an example. Okay, so the fourth term is geometric, is this. The seventh term is this. Show that the sequence converges. That is in essence asking us to show that r is between -1 and 1. So here we have the fourth term is ar cubed. The seventh term is ar to the power of 6. So once again, if we divide those, we get r cubed. And if we divide these two, we get 27 over 125. So r is 3/5. Done. It's between -1 and 1. Perfect. So the sum to infinity in the formula book is a over 1 subtract r. So we need to work out what a is, and then we can work it out quite easily. So 1.08 was a 3/5 cubed. So if I divide 3 by 3/5 cubed, 1.08 divided by, its a is 5. So the first term in the sequence was 5. So the sum to infinity is 5 over 1 subtract r. R is 3/5. So 1 over 2/5. So 5 divided by 2/5, which is 12.5. So all of the terms in this series added together would be 12.5. Okay, then the next one would be add 0, then add 0, then add 0. Right. So what if we're told the sum of the first 4 terms is 15 and the sum to infinity is 16? We need to find r, which we're going to do to begin with. So first thing we're going to do is we're going to write down what the sum to 4 actually is. So that is a 1 subtract r to the n over 1 subtract r. And we know that is equal to 15 for the first 4 terms. So we can replace n with 4. That's all we can do at the moment. Sum to infinity, a over 1 subtract r is 16, and we don't know anything else at this moment in time. Now this bit is really clever. So, and this will always be the case if we're told a sum and the sum to infinity. So here we have a over 1 subtract r is 16. Here we have an a over 1 subtract r. So we can replace with 16, which is quite nice. So 1 subtract 4, r to the power 4 is the same as 15 over 16. Bit of tidying up here, so we can get 1/16 is equal to r to the power 4, which means r is going to be plus or minus 1/2. Okay, so part B, it says all the terms are positive, find a. Okay, so now it's just a case of which one do we want to use. Doesn't matter which one you use, but would it make more sense to use this here? Be a little bit easier to deal with. If they're all positive terms, then r is going to be positive 1/2. So a 1 subtract 1/2 is equal to 16. So a must be 32. Lovely. Okay, so as always, watching this video doesn't mean you'll instantly be able to do it. Practice is going to make you better and better and better. And of course, amateurs call it genius, masters call it practice.